Pumps and turbines so are widely used in the for the energy and providing energy to the fluid. So that is increasing. So mostly the application is from increasing the pressure of one system to another. So that is by increasing the fluid pressure, and also one uses is by providing the transportation of or moving of fluid from one point to another. So those are the um, wide application of pumps. So turbines are mostly that is absorbing the energies of uh, jet towards the impeller of the turbines. Okay. Then we have your turbo pumps. So are used in hydrothermal power plants, chemical industries, buildings, and defense. They are relatively few moving parts and reasonable efficiency. Now, your turbo pumps, so it is a power absorbing machine which it requires a driver, an electric motor, or an internal combustion engine. So, a turbo pump essentially consists of blades, flow channels around an axis of rotation to form a rotor. Rotation of rotor produces a dynamic effect that add energy to the fluid. So what I have now here is the figure of a simple centrifugal pump. So we have here your electric motor, and this is the pump. Okay, and we have here your shafting. Okay, so this is a sectional view. So we have here the impeller. So parts of the pump, we have here the pump discharge at this side. Okay. Then we have here yung part na ito, which is inside this one, this curved, then we have the flat side. So ito yung tinatawag na pump impeller. So this one that is the produce the rotational effect, and it is the one responsible for increasing the pressure inside the pump. Then we have the pump suction. So which usually dito dumadaan yung flow ng fluid. So if you have a plunge here connecting dito, then you have your pipe towards here. Okay. So usually the rushes of water or the flow of water flows towards here. Dito ang pasok ng tubig or ng fluid. Then it is being rotated by means of centrifugal force by the impeller. Okay. By means of the centrifugal force, the fluid is pushed on the wall of the pump, and we have here the discharge size. So usually it increased during the process of by means of providing a centrifugal force by means of rotation ng electric motor. So yung water increases its fluid, and also as it increases the fluid, so increases the fluid's pressure. So build up ang pressure dito, then it will be discharged at this port. So yan yung pump discharge na meron tayo at this side. Then we have at this part is yung ating electric motor. So it adds to the pressure ng system, no? That is the main function of the pump. So tayo as a human being, so we have also a pump inside in our body. So that is called the human heart. Now, our human heart is a wonderful type of pump that which does not require any moving parts, and it does not require any maintenance, yet it is a highly efficient one. Now, the level of persistent or rhythmic or decidedly dynamic activity of the pump so provoke the sense of to a mechanical engineer. Now, the muscles, which weighs around 300 to 400 grams, so it produces a positive pressure of 130 mm of Hg. So that is an absolute one. And it has a negative pressure of 70 mm of Hg. So regulates with a volume flow rate of 4 to 5 liters per minute at the velocity of 0.2 meters per second. So would you imagine that? Now the heart requires to pump the blood through 100 kilometers of your linked arteries. So yung mga ugat natin. So this one is the responsible of circulating. So that is also the main function of an electric pump. So for our industry use. So sa katawan natin, we have tinatawag na small industry part that we have also other moving elements. So the same also the function in an industrial plant, that you have also other equipment in order to function yung production mo, in order you to have a good production. So the same also sa katawan natin. Now yun nga, the one of the trabaho ng heart natin so is to provide the circulation of blood inside our body. Okay, so that will be a continuously. So pag ma-worn out yan, so that is the time na ang tao ay namamatay. So that is nagkakaroon ng heart failure. So that is pag mawala ng circulation na yung dugo natin. So that is the time that our body namamatay yung tao, namamatay tayo. So in the industry, we have your circulating pump, so you can replace that anytime you wear out. But yung tao nowadays there is already implant. Okay? Now there is a circulation of blood within the heart which has to pass through collection of veins, pipes, and valves. So yun na nga. So yung mga ugat natin, so there are passes. So in actual, yung mga veins na yun are in industry use, yun yung mga pipes, okay, mga tubo. Then meron tayong mga T, so that's also meron ding mga parts ng ugat natin, so there are branches. So yun siya in terms ng katawan natin. So there are also valves that will be closed and open. The whole process works in such a manner that there is no leakage anywhere in the closed system. So need to build up the pressure inside. And during 1960, there is already invented yung artificial heart implanted, so that replace the function of the heart. So it improves material as an advances in electronics, so mechanical engineering. So have displayed a major role in making the artificial heart safe, effective, and alloy limited clinical application. So yung implant na mga heart that is electronically operated. So that means it has a battery to continuously function. So usually those batteries are nadi-discharge din. Okay, so once na-discharge yung battery na, so that is we have a time frame kung ilan months siya, then you have to replace the battery again to ensure the continuous operation of the pump. Okay. Now, one of the most common radial flow turbo machine is the centrifugal pump. So this type of pump has two main components. Okay, so an impeller attached to the rotating shaft and a stationary casing housing or a volute enclosing the impeller. So katulad ng diniscuss natin, so this is a sample of a centrifugal pump. Okay, so you have your volute casing here, the pump casing dito, then you have your suction impeller, then you have discharge, and we have here the electric motor at this side. Now the impeller consists of number of vanes that usually in a curve, or sometimes called vanes, or arranged in a regular pattern around the shaft. Okay, so ito yan siya, yung pump natin, centrifugal pump. So you will notice the parts. So we have here your outlet and we have your eye. So usually, ang pasok ng tubig is papunta dito. So I'm gonna follow this one. So papasok yan sa dito. Ang flow ng tubig natin is from here passing dito. Okay. So by means of the centrifugal force, so rotation. So usually fluid, so from mapapansin mo naman na by means of centrifugal force, if you can still remember sa physics natin, no? Okay. If you have a cylinder and it is completely filled with water, no? So, okay. Then you will be putting your hand dito sa gitna, and you're putting your, okay, let's say maglagay ka ng paddle, okay, putting a paddle here, then you try to rotate that one at a given angular velocity. Now, ang nangyayari, usually what happens afterwards, you maintain angular velocity at a certain amount. So usually nagkakaroon ka ng curvature. Okay. So that's it. Nagkakaroon ka ng curvature dito, or curve, or U-shape. Okay. Then the explanation that is, the fluid is by means of the rotation here, you provide a centrifugal force. So those centrifugal force pushes the fluid on the wall of the cylinder. So as you increases your angular velocity or the revolution per minute ng shafting, no? So also the amount of force yung pinoproduce mo doon sa from the center going out is also increases, which usually it push the fluid out of the cylinder. So palabas yun siya. So that is the yung nangyayari doon sa loob ng centrifugal pump. So the same also that is happening here. So nagkakaroon tayo ng suction of fluid at the inlet. So that is by means of rotation. Now the fluid is pushed on the side wall of the bullet casing or ng casing ng pump. Now if you continue more revolution or angular velocity ng shafting, so that produces a motion towards the outlet of the pump. So we have your pump discharge, o tinatawag natin na outlet. So yung impeller natin, so we have here, makapansin nyo yung curvature, this one. Okay, so usually dito yung eye na ito yon at part, this one yung inlet. Okay, so if you're going to look at this side, so ito ang makikita mo by means of section yan. Then makikita mo we have your impeller, yan ang kanyang profile. So yung fluid is being pushed by means of these vanes, yung vanes na yan. Okay, so may mga corresponding thickness yan, makapal dito, then manipis doon at the side. So yung profile niya, makikita mo ito, yan siya. So paliit, then palaki. Okay, so yun ang nangyayari, nagkakaroon ka ng impending force. So this is already the vane, the last one we discuss in hydrodynamics. So yung vane is being the water is being pushed by the vane and by means of the center towards the wall ng bullet casing ng pump. So that provides by means of a centrifugal force through the effort of the electric motor. Okay, so usually this is a tinatawag na bullet type of casing. So magkakaroon ka ng pressure build-up dito, pressure build-up dito, pressure build-up dyan, paikot. Then if open ito, so may matatakbuhan yung location na fluid, so it will go out here, palabas dyan. So it is already in a high pressure compared to this compared to sa inlet. So usually in inlet it has a low pressure, then it increases the pressure doon. So if you can still remember PV diagram, no? So pressure and volume. So we have the constant volume, but we have yung operation niya from 0.1 going to 0.2. Okay, so yung pressure niya increases, but we have a constant volume. So constant yung pumapasok na volume dito, the same. So we have volume entering constant here, and also volume constant leaving the pump or leaving the system. Now the energy is added to the rotating blades. So both pressure and absolute velocity are increased as the fluid flows the eye to the periphery of the vein. So the fluid then discharged directly to the bullet chamber. So you have here your bullet chamber. So your energy is transferred. So the energy from the electric motor going to the vein, so this one, is being transferred to the fluid. So that is from rotational motion ng electric motor into flow motion. So that is the change in pressure of change in flow ng ng fluid. So it will be going out, palabas doon. So transfers of energy from one point to another. Now the volute is designed to reduce the velocity increase and increase the pressure. Now the bullet casing with an increase in area in the direction of the fluid is used to produce essentially uniform velocity distribution. So as the fluid moves around the casing into the discharge opening at this side. Now we have two types of impeller. So that is, one is the open impeller, and we have your enclosed or shrouded impeller. Now for an open impeller, so ito yon, so shown in the figure. Okay, so where the blades are arranged on a hub, okay, or backing plate, or are open on other casing or a shroud side. So makikita nyo yung we have here yung curvature na. So later on you will be designing no curve na ito. So to attain the volume flow rate ng types of pump. Now so casing shroud natin dito, usually we have your back plate doon sa likod to hold the impeller properly. So and the fluid enters here and it is pushed by means of centrifugal force. So ang rotation nito is usually ganyan. Okay. So dito yung ano niya, yung hampas ng fluid, ang hampas ng impeller niya to the fluid to displace. So, flow of fluid pa ganyan. Okay. Then we have yung type of impeller, which is yung shrouded impeller, so shown in figure. So where blades are covered on both hub and shrouded end. So we have a shrouded impeller, we have no peripheral leakage. Yung mapapansin niya, we have a double hub na ito, double backing plate. Then it reinforces the whole reinforces the structural design ng blade. Okay, so yung initially dito merong isang support ng backing plate. This one have a two plate supporting the blade.